Hello everyone, welcome to Coders Camp. We are at first day of December LeetCode challenge and the problem we are going to cover in this video is house robber. So it is given that you are a professional robber planning to rob houses along a street and each house has certain amount of money. So that is the input given here in form of integer array. And the only constraint that's stopping you from robbing each of them is that adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into it on the same night. So given the integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So let's understand this with an example. So here is the given input array that represents money at each house in a street. So now we have to rob the maximum amount of money from these houses on the same night. And the only constraint we have is we cannot rob two adjacent house at the same time because it will trigger the alarm to the police. So now to understand that if we are trying to rob the house number 1, then we cannot rob the house number 2 because it is right adjacent to it. If suppose our option is to rob house number 2, then we cannot rob house number 1 as well as house number 3 because we cannot rob any neighbor house we are choosing to rob. So for example, if we are trying to plan the houses and explore all the options to come to our solution, let's take our decision tree. Let's start. We are planning to rob our house number 1, house number 2, house number 3, and house number 4, which is having the amount house 1. So now if we are robbing house number 1, then in that case, we cannot rob house number 2. It will be ruled out for house number 1. So we have to go for house number 3 or house number 1. We cannot rob both 3 and 1 because they both are neighbors. So in that case, you have to choose either of one path, either 1, 3 or 1, 1. So obviously we need higher amount. So we would choose 1, 3 here. Same way, if we are trying to take house number 2, then we cannot choose house number 1 as well as house number 3 because they both are neighboring to 2. So in that case, we can choose only 1. So that is one solution which is giving you 3. So going to house number 3, you cannot choose both 2 as well as 1 since they are adjacent. So the only option you are left is robbing the house number 1. So this is giving you 4. So finally house number 4, which is having amount 1. So if you are choosing, then you cannot choose house number 3. So you can either choose 1 and 2 and it goes on. So out of this, you will be having the best solution, which is having the maximum amount. For example, if we have more number of houses with money, then in that case, this graph will become, or this decision tree will become more complex. So how do we approach it in an easier way? So the best possible way to approach this problem by considering all possible solutions is dynamic programming. So how do we conclude this is a dynamic programming solution? So clearly, dynamic programming solution is building up the solutions from a small subproblem. For example, consider our first case, we are having only 0 number of houses. So in that case, the total number of money the robber should get will be obviously 0. So consider there is only one house. So considering one house, what would be the maximum amount of money the robber would get? The robber will obviously rob that only house without any constraint because there is no adjacent houses. So the amount and the house 1 will be the output. So case 3 would be having 2 houses. So if there are 2 houses, you can rob only one house because you cannot go for adjacent house. In that case, your solution would be max of house 1, house 2. So whichever house is having the maximum amount, you would be robbing that. So finally, case 4, which is having 3 houses, house 1, house 2, and house 3. So here, what would be the solution? So in case if you are having 3 houses, you either have to pick 2 houses, that is in the front and the back, because you cannot rob the middle house, or you should be choosing the middle house and ignore the first 2 houses. So in that case, which one would be the solution? The maximum of both. So this would be max of either house 2 or house 1 plus house 3. So from here, we will be stepping to four number of houses and finding your solution. So this approach is called bottom-up approach, that is building your solution from the smallest sub-problem to the higher one. So this is the overall logic of this problem, which is pretty simple. Though it looks complex, it is a basic of dynamic programming. You can start learning dynamic programming from these kind of problems. So this is one of such classical example of DP to understand and to bring up with a solution. So hope you're understanding this logic. We are simply going to approach this logic and build a solution to approach to the final solution. So let's see the code now. So before getting into the code, this algorithm is actually going to run in big O of n time complexity, as we are going to iterate the array only once and update our result array, and also going to work in big O of n space complexity because we're going to use DP array to store our values. So yes, let's go to the code now. So yes, let's return the basic values that, and here are the base conditions that if there is only one house, then that is the maximum value the robber could have robbed. And if there are two houses, then max of both houses are going to be the output. So yes, we have covered the base conditions. Now getting back to the actual DP solution. So DP of 0 is nothing but the house number 1's value, because this is a 0 indexed array, and 0 index is nothing but there is only one house. Considering only one house is there, what could be the maximum amount? The amount at the house number 1 is the solution. Same way, DP of 1 is nothing but there are two houses. Again, it is a 0 indexed array. So out of two houses, again, let us update of 1. So yes, so now we have to build the rest of the solution by using the logic we have seen. So let us iterate the rest of our array. So here, as I said, we are going to consider each DP array's value by not considering the adjacent houses to rob. For example, if we are at the current house DP of I, then we would consider the amounts in the current house plus what is there in the one house before that. So nums of n minus 2 is nothing but ignoring its previous house and considering the money in the previous to that, or considering the money only at the middle house, that is nums of I minus 1. So yes, that's pretty much it. After iterating all the array and updating the DP, our solution would be in the bigger array, that is the last cell in the DP. So which would be nums dot length minus 1. So yes, this is it. Let's give it a try. Okay, I made a mistake here. We have to consider dp of I minus 2 and dp of I minus 1. Why? Because we have calculated till this house what is the maximum money we could get, and from there we are going to add that to the current house, not from the houses. So this is the mistake I have done. Hope you're understanding what is the change here. So yes, let's submit. Yes, the solution has been accepted and we have completed today's problem. So yes, this runs in 0 millisecond, which is 100% faster. Hope you're understanding the logic and like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.